Hello, ladies and gentlemen. Thank you for joining me on taking notes in this YouTube video. We're on page 57 of our math notebook talking about prime factorization lesson 9.2. This first video on this page, I'm going to talk about factor trees and how to use factor trees to find prime factors or to find the prime factorization of any number. So I have the steps covered up here, and I'm going to zoom in. Now, remember, while you're taking notes, please keep in mind that these notes can be paused or stopped, and you can always write things down to get caught up and then continue the video and move on. I'm going to reveal our step number one. So step number one for finding the prime factorizations using a factor tree is to write the number at the top of the tree. Now, in this case, I'm going to use the number 240 as our number example. Okay, so there's 240 at the top of our tree. And what I'm going to do is I'm going to start us off with a couple little branches. Okay, so we've got our number at the top and we started our tree. Step number two, find a factor that can be divided into the number. Now, this can be any factor. Prime factors are best, but it could be any factor. Let's use the prime factor of 2. Okay, 240 divided by 2 is 120. So far, so good. Let's scroll down a little bit and take a look at step number 3. Step number 3 says continue finding factors until all factors are prime. So I know that 2 is prime, and I can't divide 2 by anything, so I'm going to continue with the 120. Now I know 120 can be divided by 2, because 12 divided by 2 is 6, so 120 divided by 2 is 60. And I know I can divide 60. Let me use the black branches there. I can divide 60 divided by 2 as well. And 60 divided by 2 is 30. And then 30 can also be divided by 2. And 30 divided by 2 is 15. Okay, so far so good. And then finally, I know that 15 can be divided by 2. Or not 2, sorry, 15 can be divided by 3. And 15 divided by 3 is 5. Okay. Now I'm looking at this and I don't think I can divide any more of these branches. We have prime factors all the way down. 2 can't be divided by anything besides 1 in itself. 2 is prime, and so is 3 and 5. So let's take a look at our last step here. And I'm going to zoom out just a little bit so that you can see more of the page. There we go. Okay, so taking a look at our last step, I'm going to erase that. Circle the prime factors and write them in expanded/exponential form. So I like to use a different color with this. I'm going to use red, and I'm going to circle all of the prime factors. These are all the numbers at the end of our branches on the number tree. They can't be divided any further. And I'm just going to write them down below in expanded form. They'd be written as 2 times 2 times 2 times 2, is 4 2s, times 3 times 5. And that should equal 240. I'm certain of it. And then I can also write it in exponential form. And I could write that, let's see, we have 2. How many times are we multiplying the number 2? 1, 2, 3, 4. So 2 to the 4th power times 3 times 5 equals 240. So I can write it in exponential form and save a little space as well. I'm going to zoom out a little bit more so you guys can see all of that. There we go. So this is an example of how you can use a factor tree to find all the prime factors of any given number, also known as finding the prime factorization. All right, I'm going to make a second video for the ladder method, and I will see you in that one. Have a great day.